Hi guys, so today we are going to discuss how we do some operations with vectors, and we will start with the addition. So now let's suppose we have two vectors. So we have, for example, u, and this is a vector in three-dimensional space. So it has three components, for example, 1, 2, and then 4. So the first component is a component in the horizontal direction or x direction, and then the second one is the component in the y direction, and this last one, the third one, is a component in the z direction. And then we have another vector v. So this is u, and the second one is v. It is also a vector in three-dimensional space, for example, 2, 5, and then 8. Now, when you want to add vectors, for example, u plus v, the rule is basically easy. So what you do is just, you need to add the same component. So basically what happens is, in this case, we'll have 1 plus 2. So the first is 3. And then after that, we have now 2 plus 5, 7, and then 4 plus 8, 12. And that's essentially the same thing, when you want to subtract vectors u minus v. So you just subtract the same component. So for example, we have u minus v like this. Therefore, it is 1 and then minus 2, 2 minus 5, 4 minus 8. So we'll get minus 1, minus 3, and then minus 4. So normally students don't really have difficulties when they add or subtract vectors. That's why I just want to go a bit quick with addition or subtraction. Now, I want to discuss the next one is the vector multiplication. So this is now different when we multiply vectors and when we multiply numbers, because for example, if you have numbers, you have 2 and then 3, and then when you multiply them you will get 6. But when we have vectors and then you multiply them, now I just want to introduce you, we have now two different kind of multiplication. The first one is called dot product, and the second one is called cross product. So now I'll explain to you why we have two different multiplications. So for example, let's suppose I have two vectors. This is the first one, u, and then I have now another one, v. So now if you look at one of them, for example, you see the vector u. It has two components. So when you project u on v, we will have now the component of u that's parallel to v. So let me call it u parallel. But there is another component of u here, which is the component that's perpendicular to v. So this is the second component of u. Now, the reason why we have two different multiplication because each of these multiplication corresponds to the multiplication of different components. So for example, the dot product, now it is defined as the, now for example, we have u dot v, u dot v. So this is how we write down u dot v. So essentially, this is the multiplication between the parallel component with v. So you have now u parallel times v. So what is that? Now when you multiply these two components, so for example, we have u parallel, and then let's suppose now we have an angle. You see, we have vector u and vector v, and there is an angle between them here, for example, theta. Now, if you want to get the magnitude of dot product here, which essentially we are now calculating the length of this, and then times the length of v. So the question is, what is the length of u parallel? Now, you know, for example, we have the length of vector u, and then we have this angle cosine. We have the angle theta here. Therefore, the magnitude of u parallel, it is simply u magnitude times cosine theta. So that's how we calculate the dot product. So essentially, if you have two vectors, u and v, and then you do the dot product between them, the dot product u dot v is simply the magnitude of u times the magnitude of v times cosine theta. So this is the origin actually of the dot product, the multiplication between the parallel components. Therefore, the other components will give you the other multiplication, which we call it later the cross product, but I'm not going to discuss cross product today. So we wanna discuss further now about the dot product, because normally when you have vectors, for example, we have vector u and vector v. Instead of giving the magnitude of vector u and the magnitude of vector v, what happens is you are given the components. So for example, now we have these two vectors again, you know, u and then v, and then you want to do the dot product between them. So what happens is, you know, if you try to get the magnitude of u and then times the magnitude of v, which we can do that actually, you know, for example, in this case, the magnitude of u is simply square root one square plus two square plus four square, whatever that is. And also we can get the magnitude of v, which is in this case square root 2 square plus 5 square plus 8 square, whatever that is. But then when you put these numbers into this expression, what happens is we still need to have now the other value, which is the cosine of an angle between them. So this is something that we don't have at the moment. So the question is, if you have now two vectors that are given in their components like this, how we multiply them in the dot product? So now I'll give you a bit more general first, yes? You know, for example, when you have now two vectors, for example, I have now those vectors again, yeah? So to make it easier for us, actually I want to write now these vectors using their unit vector. So now, rather than writing you with in the column form like this, I will write like this. So that's essentially the same thing, you know. When you have now u 1 to 4, this is the same as 1i plus 2j plus 4k. And also v now, you know, 2i plus 5j plus 8k. So essentially, we now wanna do the dot product between them. Yes. So this is essentially the same way when you multiply, you know, two terms algebraically. So you know we have this dot product with that. So the question is, how do we multiply them now, right? You know, essentially we can multiply them manually, like 1i dot to I, and then after that we add the next one is 1i dot 5j, and then the next one is we add 1i dot 8j. So let me just write down first, yes. So 1i dot to I, it's now, you see when you do the dot product like this, you multiply number with the number. So 1 times 2, it's 2. And then I dot I. So that's what you get first, right? And then the second one is 1i dot 5j. So 1 times 5, it's 5. And then I dot j. And next, 1i dot 8k. So that's 8i dot k. So you will expect essentially if you have 3 terms here and then you multiply by another 3 terms, you will get later 9 terms. So the next one is when you now multiply 2j with these guys, right? So what are they? 2j dot to I. So that's 4j dot I. And then next 2j dot 5j. So that's 10j dot j and so on. So probably yeah, well, let's just be patient a bit because I want to explain something from this calculation. Yes. Now, now, you know, for k dot to I, so that's 8k dot I, and then plus 20k dot j, and then plus 32k dot k. So now you probably wonder, what are these? I dot I dot j, I dot k, j dot I, j dot j, j dot k dot I, k dot j, k dot k. Well, now you need to know when you have now these guys, the unit vectors. Let me tell you again, yes. So essentially, when you plot these guys, you know, so we have now three-dimensional space, as you know. So this is the x, and then this is the y, and then this is the z axis. I, j, k, they are actually unit vectors. So I is a unit vector in the x direction, yes, and then j is a unit vector in the y direction, and then k is a unit vector in the z direction. So remember what unit vector is? That's a vector with the magnitude equal to 1, right? So now when you think about this dot product, for example, you have now this unit vectors I, and then you dot with another unit vector I. So what happens is the dot product between them will just be 1 times 1 because the magnitude of these guys are 1, and then times the cosine of the angle between them, which is in this case, if they are pointing to the same direction, because I and I, they are pointing to the same direction. So therefore, the angle between them is 0. So the value of I dot I is simply 1. Yes, and that's actually also true for J dot J. So that's also 1, and then K dot K also 1. Now, when you think about now I dot J, yeah, I dot J, so I is pointing to the X direction, and then J is pointing to the Y direction. Now, what about the angle between these guys? The angle between them is 90 degrees. So when you now do the dot product between I and J, what happens is you have now 1 times 1 and then cosine 90. And cosine 90, it's 0. So this essentially also the same thing with, I dot K, because the angle between them is 90 degrees, therefore it's 0. And then J dot K, K dot J, yeah. And then what? Essentially, if you have two different unit vectors like, ij, ik, jk, kj, yeah, so the dot product between them is just 0. So if you look at these expressions here, essentially what will survive is just this one, and this one, because I dot I it's 1, j dot j it's 1, and then k dot k it's 1. Or these terms, they simply equal to 0. So what we have now is we have 2 plus 10 plus 32, right? Because I dot I is 1, and then j dot j is also 1, and then k dot k is also 1. So in this case, the answer is 44. Now, if you want to take the easier way, when you have those two vectors, and then you want to do the dot product between them, of course, we can just do like this at the end of the day, rather than doing this lengthy calculation all the time, yeah. And you will know what happens. You will end up with now these 3 terms only. So now if you notice what happens is when you have now two vectors like this, and then you want to do the dot product, you can just do now 1 times 2, and then plus now the second one is 2 times 5, and then plus 4 times 8. So at the end, you will get a value. Now that's actually important. When you think about the dot product where you multiply two vectors, what you will get is just a value. So there is no information about the direction, because this is simply just a scalar, a value. So that's important. When you have two vectors and then you multiply them in a dot product, you will get a scalar. So dot product produce a scalar. Okay, so that's for today. See you again next time. Thank you.